All right, ladies and gentlemen, here comes the proof. We can do this. All right, I know you can do it. So I'm going to first just emphasize on the test when we have a proof, you're just going to take the given information and you're going to put that right at the top. Then you're going to take what you're trying to prove and you're going to put it all the way down at the bottom. So I'm going to take this guy and I'm going to skip a bunch of space. Now, this can be kind of tricky, like if you don't skip enough space and you're writing in something that's not easy to erase and you run out of space, then you're in a little bit of a pickle, right? So I'm just going to drop it there because it fits on my screen. And I'm hoping that I have enough space to connect all the dots. That's really what we're trying to do. We're trying to take little steps to make it all the way down here to say the thing's a rhombus. All right. And in my last video, I said what we want to use to prove that it is a rhombus on this particular problem is consecutive sides of a parallelogram are congruent, then we have a rhombus. Okay. So let me put a little check mark right here by parallelogram. That's the first thing I'm going to try to show in my proof. Then I'm going to try to show that consecutive sides, that's like if I look at this little rhombus up here or whatever it was, this side's equal to this one right here. Okay, I'm going to try to show that consecutive sides are congruent. So let's get over to our proof and let's get going on it. All right, so first thing, once you copy the given and what you're trying to prove down here, you write given over here. This is the reason I know those statements are true. And I want to go through my given and I want to mark up my drawing. So you got your drawing down and then you put down, let's see, we'll start with this one. ACDH and BCDF are parallelograms. So they're saying that the big monster guy is a parallelogram. So let's mark like this side parallel to that one and this side parallel to that one. And then they're saying that the littler one is a parallelogram. Well, it's got one little arrow here. So I'm going to put one little arrow there and it's got I can't put one arrow here. I'm going to put two arrows here. And so this side here is parallel to this one right here. Now, when I first looked at this, I thought, you know what? This guy over here has got to be a parallelogram because these opposite sides are parallel. These opposite sides are parallel. But the proof that I assigned on McGraw-Hill is one that the author has set up. So we've got to do the proof the way the author has. So I'm going to kind of walk you through what the author was thinking. The author is going to try to show that this guy right here is a parallelogram by showing that the opposite sides are congruent. Okay, if we had opposite sides congruent, the thing would definitely be a parallelogram. Now, let me back up for just a second. Do you see this given piece of information here? I haven't really explored what that is. We've been talking about trying to make this thing a parallelogram because I said that in our properties over here, or theorems, it says if we have a parallelogram and two consecutive sides congruent, then it would be a rhombus, right? So you need to look at, like what is it that we're trying to prove? And then what property are you going to shoot for to satisfy what we're trying to prove here? So I feel pretty confident I'm going to be able to get these sides congruent, like the opposite sides congruent, because I see that, this is a parallelogram here, and then this one's a parallelogram. So maybe we'll be able to subtract these two little pieces and get these two sides equal. But I want to understand what this is all about. What's this saying? BF is right here. So let me put a little tick mark on BF. And then AB is up here. Oh, these are the two consecutive sides. So they're just flat out telling us the consecutive sides are congruent. I'm going to come down here in my proof, and usually I don't suggest you do this, but I'm so confident that we're going to have consecutive sides congruent. I'm going to put it in right now. If two consecutive sides congruent in parallelogram, then rhombus, okay? And when you're looking at their little drop down and drag and all that kind of stuff on the digital, assignment, you'll see that as one of the options, and you'll drag that up into the last line right here. Okay, so let's investigate. I might not write this up exactly the way his proof is set up, but I'll show you here in just a bit. Hopefully the way that they set up their proof. Okay. And we might need to make some adjustments. So what I'm saying is when you make a proof, it's somewhat flexible. All right. So let's see, what are we trying to do? We're trying to get opposite sides equal to each other. So I'd like to say BF and AH are equal to each other. Well, I could say that, I could say right down in here, I could say that AH is congruent to CD, and I could say that BF is congruent to CD, and that's because opposite sides in parallelogram are congruent. All right. Now I'm going to use a transitive property. Like if AH is congruent to CD and CD is congruent to BF, I could say AH is congruent to BF. All right. And that's the transitive or substitution. Okay. So I'll write both here. Transitive is what I would call it, but transitive is just a fancy substitution. Okay. It's transitive or substitution. Probably don't need a little comma there. Sorry, English teachers. All right, so let's see. We've got a couple pairs of sides equal. So I'm going to put one tick mark here. You know, putting a tick mark there is a little on the dangerous side because people might think, well, we're done. We got a rhombus. So let me get rid of that tick mark for the time being. Okay. So now the next thing I'd like to do, because remember, I'm trying to get this thing to be a parallelogram down here. I'm trying to get ABFH to be a parallelogram. So let me just come down here and put that down. I'm going to try to get ABFH to be a parallelogram. Is a parallelogram. All right. And the way I'm going to do it is opposite sides congruent. If opposite sides congruent, then parallelogram. All right. Okay. So we've got one pair of opposite sides congruent. I'm going to put a big check mark right here because I've now got one pair of opposite sides congruent. Okay. But we need both pairs. I should put that. If both pairs of opposite sides congruent. So I've got one check mark. I got one pair. Now I'm going to go for the other pair of sides to be congruent. So this is going to be a little bit trickier. What I'm going to say is that AC is congruent to I don't like that little congruent sign, is congruent to HD. And again, that's opposite sides congruent. Opposite sides congruent in a parallelogram, or I could say if parallelogram, then opposite sides congruent. And then now I've got a couple other opposite sides that are congruent. BC and FD are congruent. So let's do that. BC congruent to FD. All right. Now, gosh, you know what? Let's just say, I'm just going to make up some numbers. Let's say this whole side's like 10 long. And let's say this side right here is 3 long. How long would this side be right here? That'd be 7 long, right? Let's say, well, this side we have no choice. This has to be 10 long because I called this side down here 10. And then this side would have to be 3. So 10 minus 3 is 7. That's what we're really going to do. We're going to subtract the pieces over here that are both 3 from the longer pieces that we know are congruent. Okay. So let's get that idea down that that this whole side is really just AB plus BC. Okay. So I'm going to put that down. AB plus BC is equal to AC. And HF plus FD is equal to HD. All right. Congruent to or equal to, whatever you want to say. It doesn't really matter to me. Now, will in their little drop-down proof. So we're going to investigate that, the difference the way I'm doing mine, okay? So that's called segment addition postulate. We're adding up pieces to equal the whole thing. So segment addition postulate, okay? Now, here's what we're going to do next. We're going to try to look at what we have here, like isn't AC and HD equal to each other right there, right? So I'm going to set AB plus BC equal to HF plus FD, all right? And I'm going to put the little bars over the top, even though it's really probably technically incorrect because we're trying to add links together. And really I'm saying segments here. So this is where the rub kind of comes into how you're writing your proof. And I'm trying to be a little bit flexible here. And again, we'll look at how the drop-down menus work and we'll adjust. Okay. So this is substitution, because when you look at AC and HD, they're equal to each other. So instead of having like HD here, I could put AB plus BC, or instead of having AC there, I could put HF plus FD. And that's what I've done right here. Okay. Now we know back here, where is it? We know we're trying to get AB equal to HF. So here's AB and here's HF. This is really what I'm trying to get right here, equal to that right there. Standing in our way is BC and FD. But BC and FD are equal to each other. So I'm going to do a little substitution. Instead of having BC right here, I'm going to put FD in its place. All right. And over here, I'm going to leave FD right where it is. Okay. And I'm going to leave AB right where it is. Now, look, I've substituted in there. So I'm going to say, hey, look, same answer as above. That's substitution for this one, and it's substitution for this one. Now I'm going to do subtraction. If I subtract FD from both sides, this part doesn't usually show up in a proof where you actually show the subtraction part, but I'm going to put it down here. If I subtract FD from both sides, I'm left with AB equals HF. Okay, now again, I'm using my equals and congruence symbols pretty flexibly. So hopefully that's okay with you. So I'm doing subtraction there. Okay. Now I have both pairs of opposite sides congruent. Here's another pair of opposite sides congruent. This one right here is equal to that one. And I'll put 2 tick marks because we haven't really said that they're all 4 equal yet. We're doing it right. We're going to do it right now. And then you notice here AH is congruent to BF. So since we have, we know where to go. I'm sorry, pointing the wrong thing. BF is congruent to AB. So since BF is congruent to AB, really instead of like 1 and 2 tick marks, I could just change this to a 1 tick mark and this guy to a 1 tick mark. And now I have a rhombus down here. So if 2 consecutive sides are congruent in a parallelogram, then the thing's a rhombus. All right, let's look at how their proof works over here. And I want you to try and figure out, how is their proof a little maybe more technically different than ours. We got into the congruent symbol. See how they have the equal signs without any bars over the top. So I want you to see if you can fill in all the drop downs here, not drop downs, but drag and drops. Like for example, given, right? I said that's going to go all the way up here at the top. We always put the given all the way at the top. Okay. So it's a little awkward when I put this in my video because it doesn't want to move it up there very smoothly. Hopefully yours works a little bit better than this. So thanks for watching my video. I hope this all makes sense. It's something you need to be patient with, and I appreciate your patience.